Good day, everybody. How are you all? Hope you are doing great today. Today, we are going to talk about the mean of a discrete probability distribution. So, here I go. After a coin is, no, a fair coin is tossed four times. Assume success is for the coin to land head face up. Assume that the probability of obtaining head is 0.5. What will be the mean number of heads? So, let's first, we will solve this problem, but I'll keep a quiz item for you. I will find the mean. The quiz question will be, what will be the standard deviation in this case? And the question we are trying to answer is, question for us is, what will be the mean? This is what we are trying to answer today. So why this is a discrete probability distribution? So first of all, our n, which is number of trials, is 4. Probability of success, small p, probability of success, it's all given to us, is 0.5. Okay. And we are required to find out, oops, required to find out what is mu sub x. So let me take care of that. Okay. So first of all, we have to realize, and please do not quit right away. I'll give you some important hint and tip at the end of this program. And please do not hesitate to write me comments, okay? So the x, it is given to us, x is number of success. In this case, number of heads. Number of heads obtained. Obtained in 4 tosses. So we have to think about how many times, what are the different values of x. So possible values of x are, so x can vary all the way from 0 heads, 1 head, 2 heads, 3 heads, and 4. These are all the possible values of heads. All the possible values of heads. Values of heads in 4 tosses. Okay. So we have to find, so since we can have 0 head in 4 tosses, no heads, that means 1 head out of 4 tosses, 2 heads out of 4 tosses, 3 heads out of 4 tosses, and 4 heads out of all the 4 tosses. That is, all 4 are heads. So what does it mean? We are jumping from 0 to 1 1 to 2 in number of heads, from 2 to 3, and then 3 to 4. So X is a discrete. X is discrete random variable. Discrete random variable, which is number of heads. Variable, which is number of heads. Why discrete? Because we jump from 0 to 1 to 2 to 3 to 4. Okay. Now also, this is a case of a binomial trial. So maybe you can write here, binomial trial. Binomial, this binomial experiment. Why? Is tossing of coins. Why? Because of two, because of because of because of two possible outcomes. Bi means two outcomes. Outcomes mean two results. So two possible outcomes. Outcomes or results. Well, one is a success, one is success, that is to heads, coin lands head face up, or failure is tails. If I erase this and write it. Failure is tails. So for a binomial distribution, the probability of X successes out of from N trials is given by this formula. N C X P to the power of X multiplied by 1 minus P N minus X. Okay, so let me write this clearly. The probability of success from N trials, is given as P of X is equal to this. So let's make a table now. Okay, so let's move this a little bit up. So please do not quit. I will give you an important tip at the end of this program. Okay, so X values, we can start with 0, then 1, then 2, and then 3, and then the last one is 4. And corresponding P values, P of P values. P is probability values in this case. I will get rid of these things. Okay. So p values will be given by, in this case, my n is 4 and I have 0 success. 4, 0 times p is 0.5 probability of success in each trial raised to the power of 0. 1 minus 0.5 raised to the power of 5. N is 5 minus 0. Okay. So maybe I should write it clearly instead of confusing. And I will change the color. So for a binomial distribution, the probability of X success should be X successes. Let me erase that and write. For a binomial distribution, binomial, let's say binomial experiment, probability of X successes of X successes from N trials from N trials is, let me erase that, is given as probability of X is X, this will be X, probability of X is equal to N C X small p multiplied by small p raised to the power of X, and then 1 minus p raised to the power of N minus X. Okay? Okay. Well, X successes. Okay. So NCX, let me use that a little bit below. Let me see. So NCX is combination or the number of ways that we can select X items. So this is combination. X items from N items. So this is combination, NCX, okay? And then if I move a little bit up, P, P, as I told you, is the probability of success in each trial, of success in each trial, in each binomial trial. Again, it is called binomial because you can get a success, which is head face up, or you can get a failure, which is tail face up. Okay? So, and this is N items. Okay, so let's, for fun's sake, just calculate one of these. So we know the lowest value of x is 0. So let's do P of 0. What is the probability? Probability of getting 0 heads out of 4 tosses. 4 tosses. Okay. So if I move this a little bit up, I can show you the calculation for P of 0. So P of 0 will be P of 0 is equal to, okay, N in my case is, I'm tossing the coin 4. I have 0 success, which is 4C0. How many ways can you take 0 items of 4 items out of total of 4 items without regards to order? How many ways? Okay, that will be multiplied by probability of success. We discussed this before, is 0.5. Probability of success of getting ahead. That is raised to the power of x, okay, and then multiplied by 1 minus 0.5 raised to the power of n. I'm tossing the coin, total of 4 minus 0. Okay, so that's your P0, probability of getting 0. Now, first thing I have to calculate is what is 4C0. Again, this is number of ways in which you can select 0 items out of 4 items. 4 items without regard to order. Without regards to order. Okay. So, if I use this to use this. Okay. So if I move, oops, sorry. So I'll need to move this a little bit up. So I have a TI-84 calculator, which makes life breeze. I will type 4, then I will press the math key. Then I will highlight the PROB formula on the top. Then I will scroll down to NCX. And I will get in my calculator 4P with a square, empty square at the bottom of P, subscript as a subscript, where I will type 0 here. This is same as, sorry, my mistake. This is 4, and then C and 0, okay? When I type in 0 and hit enter, I get what are the ways in which you can select 0 items out of 4 without regards to order? So 4, then math key, which is the third key in the first column on the left, then highlight PROB. This should be PROB on the top, okay? And then scroll down to, so 4, then math button, highlight PROB, scroll down to NCR, and in the empty square, I type in 0 and hit, and that is only 1. So, point to note, 4C0 is equal to 1. We will also need to calculate 4C1, which is number of ways in which you can select one item out of four items. Out of four items without regard out of four items without regards to order. Regards to order. Okay. So if I move up a little bit, let me calculate using my calculator for C1. So for C1, same process. 4, then math, then highlight PROB on the top, and then down to NCR. We will get in our calculator 4C, a square subscript box, type 1 here, and enter. The answer is 4C1 equal to 4 math PROB NCR 1 is 4. So is 4. In the same fashion, we'll also calculate 4C2 equal to 4 math PROB 3, then 4 C2. That is how many ways in which you can take two items successfully out of 4 without regards to order. And that is 6, comma 4C3 equal to, so 4, again, math, highlight PROB on the top row, go down to NCR, 3, and hit enter. 4C3 is 4. And the last one, we will be interested how many ways you can select 4 items successfully out of 4 without regards to order. So 4 math, PROB, NCR in the box 4, and the answer is 1. Okay, so maybe I should write it closer. Okay, so we are interested in these 4C0, 4C1, and of course the other, the 4C2, 4C3, and 4C4. Now you might ask me, why do I need to calculate this combination? Look at the formula for the binomial probability of X successes out of N trials. Okay. So I will, just for your sake, I will calculate and show you how to use this formula. So P of 1, that means probability of one success out of 4 trials, out of 4 tosses or 4 trials, is given as, is equal to 4C1 small p, probability of getting ahead in one single toss is 0.5 raised to the power of 1, then then multiplied by 4C1, this is multiplied by dot 1 minus 0.5 raised to the power of 4 minus 1. Now we already know 4C1 is 4. So this is 4 times 0.5 raised to the power of 1 times 0.5 raised to the power of 4 minus 1 is 3. In other words, it is 4 multiplied by 0.5 raised to the power of 4, which is equal to So in your calculator, you do 4 multiplied by 0.5 exponented to 4, and the answer is 0.25. The answer is 0.25. So that is probability of one success out of 4. Hence, we will make a table. Okay. Remember, the lowest value of success is 0. Highest value of success is 4. Okay. So in the same fashion, let's do one more calculation. Let's do P of 0. Okay. So that will be 4C0, 0.5 multiplied by 0.5 raised to the power of 0, 1 minus 0.5 raised to the power of 4 minus 0. Okay. This is, just to make sure, this is 4 minus 0, that is the exponent. Or 4C0, I have already found out. What did I find out? Let's find that one more time. 4C0 is 1. So this is equal to 1 times 0.5 raised to the power of 0. Remember, anything raised to the power of 0 is 1. And 1 minus 0.5 is 0.5 raised to the power of 4. Or 0.5 raised to the power of 4. So P0 is equal to 0.5 exponent to 4. And the answer is 0.5 exponented to 4, and that will be 0.0625. Okay, so let's prepare a table. Okay, so we have the different values of x. So x, different values of x, and corresponding values of the probability of x. Probability of x. So 0, 1, 2, 3, and let me make it a minute. 1, 2, 3, and 4. So we have already done the calculation for x is 0, probability of 0 is 0.5 raised to the power of 4 is 0. This is 0.0625. Okay, corresponding probability. For x equal to 1, we also did the calculation. It is 0.25. Now we do need to do the calculation for 2 and 3 and 4. 2, 3, and 4. Okay. And you can do the calculations and show this probability of x equal to 2 is 0.375. Okay. And x equal to 4, x equal to 3, the probability is 0.25. And probability x equal to 4 is 0.0625. Again, what are we doing? For example, when x equal to 4, it is 4C4 multiplied by probability 0.5 raised to the power of 4 multiplied by 0.5, 4 minus 4 exponent is 0. Okay, so it is basically 4C4 times 0.5 raised to the power of 4. Okay, and this is the answer. This is the corresponding probabilities value. okay, for the different values of x. Now we got to find the mean. Please do not quit. I will give you some important tip at the end of this program. And please remember my quiz coming up. Okay. So if I move up now, so my mean, the mean of a discrete probability distribution, we all know, is given by sigma x multiplied by corresponding probability, right? Okay. Let me times p of x. So in our case, mu x, the mean, will be equal to 0 times 0.0625 plus 1 times 0.25 plus 2 times 0.375 plus 3 times 0.25 plus 4 times 0.0625. Okay, so this will be equal to mu x is equal to 0 times 0.625 is 0, 1 times 0.25 is 0.25, okay, and then 2 times 0.375 is 0.75, plus 3 times 75, plus 3 times 0.25 is 0.75, plus 4 times 0.0625 is 0.25. Okay, so if I create some space, okay, move this on. So this is mu x. Okay. Mu x is equal to, it's 0.25 plus 0.75 plus 0.75. I ignored the first term, which is 0. Okay. Now let's do something different. Let's take 0.5 out from each term. That is, the first term will be 0.25 divided by 0.5 plus 0.75 divided by 0.5 plus 0.75 divided by 0.5 plus 0.25 divided by 0.5. So this will be mu x again over here. Mu x will be 0.5, 0.25 divided by 0.5 is 0.5 plus 1.5. 0.75 divided by 0.5 is 1.5 plus 1.5 again plus 0.25 divided by 0.5 will be same as before, which is 0.5. And remember, on the outside of the parenthesis, we have the term 0.5. So what do we have over here? If I create some more space, you will see an interesting trend. So mu x is equal to 0.5 times, if you add all this term, 0.5 plus 0.5 is 1, and 1.5 plus 1.5 is 3. Basically, inside the parenthesis, we have 4. Okay, so what is the implication of this? The implication is very simple. And let me change the color of the key. Okay, color of the ink. So mu x, what is p? Is equal to p, 0.5 probability of success in each trial is p. And what is n? N is 4. So for a binomial distribution, for a binomial distribution, which is a special case of a discrete probability distribution, mu x is equal to mean is given by n times p, which in this case is n is 4 multiplied by 0.5 is 2. So what does it mean? It means on the average, out of 4 tosses, we will get two heads because the mean value is 2. So usually we write straight away for binomial distribution, mu is equal to n times p. Here I wanted to show you that actually this mu equal to n times p is derived from the formula for the mean of a discrete probability distribution, which is this formula. This is the, let's see if I change, this is the formula for mean of a discrete probability distribution. Discrete probability distribution. What is it for each values of x? X is a discrete random variable. Here x means number of heads, which varies all the way from 0 to 4. It can happen that we do not get any head at all when we toss the coin 4 times, then x is 0. Okay, so if this is the formula, then we use this formula to calculate mu x, and when we do the simplification of the formula for the special case of a discrete probability distribution, the mean of the distribution, uh, when it is a discrete binomial probability distribution, the mean boils down to mu x is n times p. N is the number of trials, p is the probability of success. Our total number of trials, we toss the coin 4, n is 4, probability of success in each trial, probability of getting a head is 0.5. Hence, mean is n times p, which is also the same as the formula that you get from a discrete probability distribution formula for the mean, which is n times p. Okay, actually for discrete probability distribution, mean is sum of each value of x multiplied by its corresponding probability. Okay, so I stop here today. If you have any question or comment, write me a note. Please write me in some notes. I love to see your reaction and I will respond to all of you. And if you like this video, share with your friends. And do not forget, let me remind you, the quiz problem that we are going to solve later on in the next video is what will be the standard deviation in this case. That is, we are tossing a fair coin 4 times. What is the standard deviation of the heads? We already know the mean of the distribution is 2. That means out of 4 tosses, on the average, we will get 2 heads. So your question to answer is, what will be the standard deviation in 4 tosses of a fair coin? Okay, standard deviation in the number of heads. I stop here today. If you like this video, share with your friends. You and your friends, please subscribe to my channel, Math Science Topia, by hitting the red subscribe button at the bottom right corner. I've solved all kinds of math problems in my channel just for you. Okay, so please subscribe and please give me a thumbs up because this motivates me to produce more useful videos just for you. Like in this video, we proved why the mean of a binomial distribution is n times p. Okay, again, please come back tomorrow when we are going to attempt the quiz problem, which is to find the standard deviation of a binomial distribution. Okay, take care. Have a nice day. See you next time.